where B is our x-intercept. So we are told this is our x-intercept. So if this is our x-intercept, then meaning we know the y value of this x-intercept. The y value of the x-intercept is 0, but we don't know the x value, right? So we don't know the x value of B, but we know the y value of B is 0. Great. And then the graphs intersect at A. So at this point, G and F are equal, right? That's what that means. And then point E lies on F, so you got a point E over there. So you have point E here. And C is a turning point. Oh, okay, great. So C is a turning point. And also, C is a turning point. Even if it's a turning point, we also can see, they didn't say it here, but we see that C is a y-intercept. So we know the x value of the y-intercept is 0, but we don't know the y value of the y-intercept, right? And they're saying that C is a turning point. So we know how to calculate a turning point, right? We know how to calculate a turning point. And D is the y-intercept of G. So D again is the y-intercept. So we know the x value of D, but we don't know the y value of D, right? But we know it's a y-intercept. So that's what we know. Great. So all right. And the last thing that you need to identify here is this. This is an asymptote. This is an asymptote of G, and G is an exponential function. So we know this exponential function. The general formula of an exponential function is Gx is equal to a p power x minus q. All right, and we know that an exponential function only have one asymptote, and it's a horizontal asymptote. So it's y is equal to negative q. That's basically what an asymptote. It's always going to be this. If this was positive q, this was going to be positive as well. Since it's negative, this is going to be negative. So I see asymptote, it's y is negative q. In this case, therefore, our asymptote is negative 4. So this, my friend, is negative 4. Let me bring it black color. Negative 4. Great, great. Now let's answer. Let's answer our questions. It's gonna be easy when you're down answering your questions, right? After roaming around and understanding the whole thing. So now 5.1.1. Write down the coordinate of D. Ooh, so that's D. And we already have identified the y value of D, right? So easy. The x value of D is 0. Why? Because it's a y-intercept. The reason, because D is a y-intercept. D is the y-intercept of G. Now you need to find the y value of D. So you have G of x, that's the equation that we have, minus 4. Okay, so to find the y value of D is we just have to substitute the x value of D in this equation. So the y value of D is half power, and we already know the x value of D is 0. So and then you can just punch this in calculator if you want to, but half power 0 is 1 minus 4. So the y value of D is negative 3. Therefore, D is 0 and negative 3. And that makes sense, right? The reason why it makes sense is because the y-intercept is negative 4. So this is negative 4. So it makes sense this is negative 3 if this is negative 4. Makes sense to be less, to be little bit upper than negative 4. Okay, or greater than negative 4. Right. So now we've discovered that D is actually the y value of D is, let's write that down because I'm going to remove this, it's negative 4. Okay. Sorry, negative 3. And you get your marks. 2 marks, so you get 1, 2. That's your how you get your marks. And from here, let's wrap this off. Now 5.1.2, they want us to calculate the range. Right, range of G. So what is a range? Range is like a domain, right? So range just means that the area that this graph could possibly exist, right? So if you're looking at this G here, it can only exist, it can't exist below here. It can only exist from the y is equal to -4, or it can exist from the asymptote going up. That's the range. Can exist anywhere here. That's the range. It cannot exist here, so it cannot go below the asymptote. So the range here, we just say, oh, this graph can exist greater than -4, and it doesn't have to touch -4, right? Because remember that the graph doesn't touch the asymptote, so you don't have to say greater or equal to. You just say it has to be greater than -4. And the other way to write this, you can say y is an element of -4 to infinity. Right, the same thing, depending on how you want to phrase it, but either way you get a 1 mark. All right. Let me know if you have questions on range and domains. I know sometimes it confuses a lot of students, but yeah, I think if you understand this way, that the ranges can exist anyway in the y-axis, and a domain can exist anyway in an x-axis. All right. I mean, just for curious sake, I don't think we have that question here. So what is the range of f? What's the range of f? What is the range of f? You see that f in the turning point, that's why I call it a turning point. Here in the turning point, it cannot go beyond the turning point. It can exist here below the turning point, but it cannot exist above the turning point. So the range of this is always going to be from the turning point, so it touches the turning point and it goes down. So that's the range. So the range of this will be y is less than, yes, or equal to the turning point, so the y value of c. Even calculates the y value of c. And you see, I say equal to y because it touches the turning point and it goes down. So the y value of c. And this could be written as, or you can write this as y is an element from -infinity to, so it goes from -infinity all the way to, from negative all the way to the y-intercept, so to y value of c, and you close it. This just means that this and this is the same representation, and this is the same representation. All right. So yeah, so that's how you do this. Let me know if you have any questions on range and domains. I'm happy to really go through this because I know a lot of students are always confused about range and domains and intimidate a lot of students. So, but I know you're not going to be intimidated by this question anymore. And feel free to ask. Coordinate of A. What happened to my A? This is 0. All right, coordinate of A. So coordinate of A, how do you calculate the coordinate of A? So that's A. We know A is the x-intercept, so easy. So we have a function g of x is equal to half power x minus 4, right? What do we know? We know that we know the y value of x, but we don't know the x value of a. So we know the y value of a, we don't know the x value of a. So g of the x value of a, that's what we're trying to calculate. And we know that the y value of a, this is the y value of a, g of xa is y value of a, and we know that is 0. So 0 is equal to half power xa minus 4, right? This is the same thing. And then from here we just solve for xa. Okay, so how you do this, you have take the negative 4, put it on the right hand side, become positive 4 xa. And again, and if you check our previous videos when I was trying to solve this question here, right, that's what you're going to be doing here. So a little bit of notes. What you need to remember here is this. So if you have a is equal to x is equal to a is equal to 2, if laws of exponent, if a and a are the same, bases are the same, therefore you equate the exponent. So your answer here, x is equal to 2. Those are laws of exponent. So that's what you're going to be doing here. So essentially you want to make this half and make that half. So we want to make 4 half power something. So half and 4 is, if you have half power negative 2, that is 4, right? You can find it in calculator. Half power negative 2 is 4 xa, so therefore xa is equal to negative 2. So that x value of a is negative 2, so a is negative 2 and 0. And that's your answers, and that's 2 marks, so you get your mark and your mark over there. Right, so we find the x value of a, so let's write that down. So you have negative 2 and 0. All right, great. We're moving. So now let's find the value of a and q. Value of a and q, values of a and q, values of a and q. Where's a and q? So a and q, we're looking at this here, f of x. So looking at f of x, f of x is equal to ax squared plus q. Okay, and find the values of a and q. Okay, first thing first that you need to know here is a represents the shape of the function of the quadratic graph, right, or parabola graph, right? So in this case, if a is greater than 0, so let me just, if a is greater than 0, therefore the graph or the parabola graph will look like this. If a is less than 0, the parabola graph will look like this. So from this parabola graph, we already see that a is negative. From that fact, a is less than 0, a is negative. Okay, great. That's one fact. And q, this is a y-intercept. It's always going to be y-intercept. Let me bring this up. So you have essentially the standard equation is f of x equal to ax squared plus bx plus c. Okay, so this c is always your y-intercept. So c is always your y-intercept. So in this case, this is our y-intercept. And what is the y-intercept? Y-intercept is c. Our y-intercept is c. So q is equal to the y value of c. That's what q is. Q is equal to the y value of c. So we can find the y value of c. Can we? Maybe we can, maybe we cannot. We'll see what are other ways of doing this. But we can actually find a couple of things here. We can find, we know a lot, actually. We know a lot. We know the y-intercept. Let me just bring a different column. So we know that f touches a, and we know a is negative 2 and 0. So let's use that information, right? So we know that a is negative 2 and 0, and a is part of the x-intercept of f. So meaning where there is negative 2, meaning f of negative 2 is 0. So you have a where there's x equal negative 2 squared plus q, that's equal to 0. So negative 2 squared is 4, so 4a plus q, that's 0. And therefore q is equal to negative 4a, that's first equation. So Q is equal to negative 4a. And what else do we know? We know that E as well is part of this parabola equation. So we know A, we know E, right? So let's do the same thing. So we know that E is 1 and 3, right? So meaning f of 1 is equal to 3. So where x is 1, f of 1 is 3. So you have where there's x, you just put 1, sorry, squared, plus q is equal to 3. And then 1 power 2 is 1, so you have a plus q is equal to 3. And that's the second equation. And from here, you can just substitute this first equation to the second equation and then just solve for a. That's what you would do. So you can have a plus, so q is negative 4a. So you have a minus 4a is equal to 3. A minus 4a, that's negative 3a is equal to 3. Therefore, a is equal to negative 1. So a is equal to negative 1. And then if you have negative a is equal to negative 1, and then you can substitute your a here. So your q is equal to negative 4 times negative 1. Therefore, this is equal to positive 5. So q, is equal to positive 4. So your q is positive 4. So your answer then, f of x is equal to negative. And we expected it to be negative, by the way. A was expected to be negative. You have negative squared plus 4. Boom. And that's your answer. That's your answer, right? Make sense? So let me write this up here. Now f of x is equal to negative x squared plus 4. You need to remember that. And you get your marks. How many marks is this? This is 4. So you have 1 for A and 1 for Q, and 1 for actually doing this, and half for this and half for that. That's how you get your marks. All right. Let's go to 5.3. 5.3.1. Length of CD. Where is C? Where is D? CD. Oh, by the way, now they wanted to find the length of CD before I get excited. So where's C? And there's D. Now we need to, for us to find the length of CD, we need to identify what is C. Why is the y value of C? And remember, the y value of C is 4. Because C is the y-intercept, and the y-intercept is always gonna be this value here, right? So that's the first thing. First thing first, y value of C is equal to 4. Why? Because C is the y-intercept. C is the y-intercept of F. That's what this is. Right, so from here, now the distance from, let me just change this. Oof. Oh, I have it. I have it black here. So I have 0 and 4. Now the distance from 4 to negative 3 is easy. So you have, if I have to write this down myself, so you have 4, 3, 2, 1, 0, negative 1, negative 2, and negative 3. I mean, you can use the calculative one too, but I think also this is an easy way of doing this. You can actually just count, because it's countable. Count the number of steps that you're moving. So this is 1, 2, 3, 4, 5, 6, 7. That's the distance between C and D, 7 units. CD is equal to 7 units. That's basically how we do it. Or you can use a distance formula between C and D that's still acceptable, and this way as well is still acceptable. And how many marks is this? It's 2 marks. It's too easy for a distance formula. So you get 1 mark for this and 1 mark for that. That's basically where you get those 2 marks. Now let's do 5.3.2. 5.3.2 equation, determine the equation of a straight line through A and D. So equation of a straight line through A and D, right? So essentially what's happening is here is you have, assuming you have a straight line. Let me just write it black, bring in like that. Okay, let's make it a straight line. It's not that bad. Not too bad. A little bit. There we go. That's better. So you have A and you have D. So let's say that's the straight line. So now what they are doing, they're saying equation of a straight line through A and B. So determine the equation of a straight line. That's basically what they're saying. So you have, let me just write this. You have A, which is -2 and 0, and then you have D, which is 0 and -3. Easy. Now, there's a couple of ways of doing this, but one thing for sure, the equation of a straight line is y is equal to mx plus c. That's a straight line. That's what we want to do. So we need to be able to identify the gradient first, right? To do this, what I would do is, the gradient is essentially the slope of this line, so which is yd minus ya over xd minus xa. So the yd is -3 minus ya is -2, xd is 0 minus, this is 0, this is 0, is not -2. The y value of a is 0, but the x value of a is -2, and then this is equal to -3 over 2. So that's your gradient, and the gradient is negative. That makes sense because the slope is of this is decreasing, it's going down, so the gradient is negative. It's negative. That makes sense. And then from here, you can use this equation. You can just take A or D, doesn't matter. I'm choosing a values of A. You can also choose the values of D if you want to. So what is the y value of A? The y value of A is 0. The gradient is -3 over 2. X minus the x value of A is -2. So you have y is equal to -3 over 2, x plus 2, and then y is equal to -3 over 2. So what you're doing, you're removing the brackets. So you're gonna have x, -3 over 2 times x, that's -3 over 2x, -3 over 2 times 2, which is -3. Boom. So that is the equation of a straight line through A and D. And you get 3 marks, so you get the mark for that, and you get a mark for a gradient, and you get a mark for substitution. Boom. So that's how you get your full marks. Now let's do 5.4, right? Almost there. We are almost there, right? Almost there. Almost there, right? Just bear with me. 5.4.1. I don't like long videos as well, so I understand. F of x greater than 0, right? For each values of x is f of x greater than 0. So now they want you to identify the values of x where f of x is greater than 0. Now what is f of x? F of x is equal to -x squared plus 4. Now they want to say find the values of x where this is greater than 0. Easy. So you have -x squared plus 4 is greater than 0. Just so for x. So you have -x squared. If you take that 4 to the right hand side, it becomes -4. And then you divide by -1 on both sides, because when I cancel that negative there, this on your left hand side becomes x squared. But because you're dividing by negative on both sides, that's very important. If you divide by negative on both sides and there's an inequality sign, that sign changes. So this is going to be less than instead of greater than. It's going to be less than 4. Make sense? And then from here, you can now introduce the square roots on both sides. Okay, and you're gonna have x. So this is plus or minus 4. Remember, if you introduce a square root, you need to always put a plus or minus. That's very important. 2 rules here. If you divide by negative, your inequality sign changes. And then if you are introducing a square root, remember to put a plus or minus. So essentially, this is equal to plus or minus 2. I'm putting an equal sign here for a purpose, because now you have 2 values here. You need to now identify which values of x is this true, right? So then you need to draw your number line where you have x is equal to negative 2 and x is equal to 2. Now you need to bring in your calculator here to able to answer this question now. So what you will do is you will take a number, any number that is between negative 2 and 2, which can be 0. Take that number and put it in this equation and see if you're getting a positive answer or negative answer, right? So in this case, if you put 0, you're going to get a positive answer, right? So this is going to be positive. Now, again, take any number that is greater than 2. There can be 3. Put it in here. So we can say 3, negative 3 squared plus 4. That's negative. So you have a negative. And then also, again, take any number that is less than negative 2. We can make it negative 3 if we want to. We're still going to get the same answer, negative. So what is the question? What is the values of x where f of x is positive? F of x is only positive in this zone here. So your answer is x is between negative 2 and less than 2. That's your answer. X is between negative 2 and less than 2. So we have a situation like that. And if it was greater than, therefore this is going to be closed, and so you're going to have like that, right? If it's greater than or equal to, but it's not, just greater than. So it's going to be like that. Make sense? If this doesn't make sense, please let me know. I'm happy to redo and just answer your question and give more clarity on this. All right, so let's do 5.4.2, the last one. 5.4.2. So how do you do this? F decreasing. This is easy. You can look at the graph. So you see that if you look at this, you see that F is increasing. So F from here, F is increasing. Okay, F is increasing, F is increasing, F is increasing until here. So meaning F is increasing between, I can actually write this down, F is increasing when between x negative infinity to 0. F is increasing. But if now F is decreasing here, so F is decreasing. So F is decreasing between x is greater than 0 and less than infinity. Now, if you say greater than or equal to 0, that's not true, because when x is 0, it's not decreasing or it's not even increasing. It's stationary at that point. At this point, F is stationary. It's not going up or down. So it's only decreasing when it's greater than 0, and it's only increasing when it's less than 0. Okay, so this f is decreasing. Boom, this is the values of x. And you get your 1 mark. That makes sense. This is 1 mark. Yeah, so this was the longest video. But yeah, but thank you for joining. Thank you for staying this long. I hope this makes sense and I hope this help you. If you have any other questions on this video, please let me know. I'm super tired and it's late. I'm actually recording this video at 3 a.m. and it's Saturday morning. And I'm doing this for you. So yeah, so if you really like the content I'm creating, please make sure you destroy that like button. I need to go and sleep. Yeah, and this is gonna help us to help more people, and it's gonna help me grow the channel as well, and making more and more professionals. I have a lot of ideas I need to do, and I'm excited to do that. So, but I'm gonna need you to. The only thing I need from you is to comment, destroy that like button, and destroy that share button. And if you're a new member, please, 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 please subscribe and welcome to the family. See you in the next video. Boom.